This is Advanced Algebra, Lesson 2.6, the graph of y equals k over x and the graph of y equals k over x squared. So in Lesson 2.6 we're going to be really exploring inverse variation and inverse squared variation. Before we even start the lesson, I just want to do a little mini review here about the different quadrants. There are 4 quadrants on our coordinate plane, and with our quadrants 1, 2, 3, and 4. Notice they're numbered counterclockwise. Need to have that one working in activity 1 here. What I'd like you to do is right away stop the video and do activity 1 from your textbook. It's also listed right here. Start the video again when you've had a chance to work through the 6 steps. Alright, let's take a look at your findings from the activity. You were to graph the equation y equals 10 over x in a standard window, and you notice that the graph appears in quadrants 1 and in quadrants 3. You are asked to explore what happens when your values for x increase. And so as you notice, if you trace along your graph, as your values for x increase, you get closer and closer to the x-axis, so your value for y is closer and closer to 0. When we look at our negative values, the smaller those values get, once again, the closer your y gets to 0. So now in step 3, or actually, I'm sorry, in step 4, they ask you if it will ever intersect. So will it ever intersect the x-axis? Well, if we think about this, the numerator is 10, so y will never be able to be 0. So it's never going to intersect the x-axis. So let's see what happens if it will intersect the y-axis. Well, if it's going to intersect the y-axis, that means our value for x needs to be 0. But if you look at it's a variation equation, and x is in the denominator, so we can never have x be 0 because we can't divide by 0. So that means our graph is never going to cross the y-axis either. And then the last step was to have you explore some other graphs of different values of k other than 10. And as you graph those, none of those graphs look any different as far as they never intersected the x-axis or the y-axis. Before we explore this summary graph here to the right, I would like to take a look at some vocabulary that is discussed in this lesson. The first one is branches of a hyperbola. So the name of our graph that we just looked at here in this activity is called a hyperbola. So our graphs of inverse variations are going to be in a hyperbola. And so we have 2 branches of that hyperbola. They happen to be in quadrants 1 and 3. We also have something called asymptotes. Say that now, asymptotes. What that is, it's a line approached by a graph of a function. So in this situation, in this graph, we actually have 2 asymptotes. We have the x-axis and the y-axis both. Both of these lines are approached by our graph but never reached. So an asymptote is that line that is approached but never reached by your graph. Your asymptotes, as you study further in mathematics, will not always be the x and y axis. It just happens to be for our inverse variation here and in the inverse square variation that we're going to study later on in this lesson. The asymptotes happen to just be the axes in this situation. And then the other piece of vocabulary that I just want to touch upon here is discrete set. And that's a set in which there is a positive distance greater than some fixed amount between any 2 elements of a set. What I'd like to do is actually look at that in terms of a graph. So if you notice the graph that I have attached to this note set, in your reading they were comparing a number of workers to the time that it takes to complete a job. And here you'll notice that this graph is not a continuous curve like some of the other graphs that we've been studying. It's actually points here. It's made up of a series of points. And that's because we can't have partial workers, so our independent variable here can never be, it will always be a positive value, a non-negative value. So that's why we have just individual points here and not a nice curve, solid curve. When looking at our inverse variations, we're going to look at another summary graph like we did for the direct and the direct squared variations. So as you see here, our direct I keep saying that incorrectly, I'm sorry. Oh, I know why I'm saying it incorrectly. This graph is incorrect and it's got a typo in the graph. Unfortunately, I copied this from the text, so I cannot retype that for you. So we're just going to put it here inversely. So make sure you change that on your note set. Alright, so we're going to look at the graph of y equals k over x, and in words that says y varies inversely as x. We notice that our graphs have two branches in quadrants 1 and 3 when k is greater than 0. When k is less than 0, we land in quadrants 2 and 4. So let me mark these on here, 1 and 3 and 2 and 4. These graphs of these curves, these branches that land in the quadrants is called a hyperbola. Okay. Domain and range. We need to look at domain and range. So when you look at these graphs, when you look at it horizontally, it looks like it goes forever in that direction, it goes forever in that direction, but we know that it never hits 0. So we know that it's all reals except for 0. And then when we look at it in terms of our y values, our range, we never hit 0 either. So y will never be 0. We have the asymptotes then, which is our x-axis and our y-axis. We also have some symmetry. They're reflection symmetric to the line y equals x and to the line y equals the opposite of x. So we also have some reflection symmetry as well. In the second half of this lesson, we're going to explore the graph of y equals k over x squared. So there's another activity that I'd like you to do that is very similar to the activity that you did at the beginning of this lesson. So please stop the video at this time, do activity 2, and start the video, and we will discuss it when you are finished. Let's look at your findings from activity 2. The first step was to graph the function y equals 10 over x squared in the standard window. The resulting graph appears in quadrants 1 and 2. Why do you think this graph does not appear in quadrants 3 and 4? Well, if you look at our denominator here, it's going to be x squared. That value, no matter what value you put in there, will always come out positive. So we will never have any values of y. Our function will never be negative, so that's why it always stays in these top two quadrants. The second step was to have you trace along the curve to a positive value of x. So as we're tracing along the curve to positive values of x, once again we continue to approach that x-axis, so our y is getting closer and closer to 0. And same thing if I go the other direction. Once again, I am still approaching the x-axis, so my y is getting closer and closer to 0. Let's look at number 4 here. Does the graph of y equals 10 over x squared ever intersect the x-axis? If it does, give the coordinates of the points of intersection. If it does not, explain why or why not. It's the same as above. If we have a numerator of 10, whatever we put down here will never equal 0. And the other part of that, so we know that if y is never 0, it's never going to cross the x-axis. And here in the second part, if we can never put 0 in place of x, we are never going to cross the y-axis because we can't divide by 0. And so the last one says, trace the graph close to x equals 0 from both the positive and the negative directions. How does the graph behave near x equals 0? Why does it behave this way? Okay, well, the graph goes to infinity. It just keeps on going up. The denominator keeps getting smaller, and as that gets smaller, then the values for y keep getting greater. Because if we're going to divide 10 by a smaller number, our function value is going to get greater. So it's just going to keep going up and up and up, getting closer and closer to that y-axis, but it's never going to get there. Alright, so here's that summary graph again. This time at least it's accurate. It has inversely, and it gives us both values for the range. So let's take a look at this a little bit more closely. So y equals k over x squared, so y varies inversely as the square of x. So let's look at what that appears, or how that appears graphically. Let's first look at when k is greater than 0. We're in quadrants 1 and 2. Okay. We know that it approaches the y-axis and it approaches the x-axis. So our domain is going to be all values except for 0. So it's not going to hit the y-axis. And the range then, if we look at its vertical, it's only in quadrants 1 and 2, and it never hits the x-axis. So we know that it can't be everything greater than or equal to 0. It just has to be greater than 0 because it never hits 0. And then same thing with when k is less than 0, now it lands in quadrants 3 and 4. Our domain is still all reals except for 0 because it's never going to hit that y-axis. And the range this time, instead of being quadrants 1 and 2 where they were positive values, it lands in quadrants 3 and 4 where y is going to be, our y values are going to be negative. Or I'm sorry, less than 0, not negative. Less than 0. Sorry, let's try that again. They are going to be negative. So they just can't equal 0. So our range is y values are less than 0, and our x values is all values of x except 0. We have asymptotes once again. We have the x-axis and the y-axis. Our graph approaches those lines but never reaches it. And then we have some reflection symmetry once again. In this case it's the y-axis. This concludes our study of the graphs of all of the 4 variations: direct, direct squared, inverse, and inverse squared. And this also concludes video 2.6.